All right, today we're going to be looking at parallel lines and some angles. It's a little bit of a mixed bag of things. A lot of new terms today, some terms that you already know, especially on this first page. This first blank, parallel lines. Parallel lines are coplanar lines. That means they're on the same plane, just like collinear means on the same line. Coplanar means on the same plane, that do not intersect. On a diagram, the way we mark those is either a triangle or an arrow. Your book tends to do arrows like this. That's just not my preference. It doesn't matter though. You can mark them that way also. One thing to be careful of is don't assume that two lines are parallel just because they look like they are. Okay, we tend to not go just by how things look in geometry. So the symbol for parallel lines is this, which most of the symbols in geometry make a lot of sense. Because do these lines look parallel right here? Yes. And beside that, it looks like the two L's in the middle of the word parallel. It's the perfect symbol for this. Now, in this diagram, which lines do we know are parallel to one another? Well, we see that these two are both marked the same way with an arrow in the middle. So line AB is parallel to line CD. Also, we see that these are marked with 2, and that's how we keep it from getting confusing. EF isn't parallel to AB, EF is parallel to GH. Line EF is parallel to line GH. Another type of lines that you already know about are perpendicular lines. Perpendicular lines are lines that intersect at right angles. The way that we mark that is with a square near the vertex. Again, don't assume that two lines are perpendicular just because they look like they're perpendicular. That's going to happen a lot. You're going to have line where it's like, that looks like it's a right angle. You can't just assume that. You can assume straight angles. If something looks straight, you can assume that it is straight. But you can't assume right angles. So the symbol for perpendicular is this thing that looks like an upside down T. Now, occasionally I have a student who is like, you just said that it's the perfect, we always use really good things. Why don't we use this for perpendicular? And I said, well, why don't we? What else could that possibly be confused by? What does that look like? Yeah, it looks like a plus sign. Okay? So that's why we don't use that, but we use part of it. That's the symbol for perpendicular. All right, lines that are known to be perpendicular. So here we have this square, so the two lines that meet there are perpendicular. So line AD is perpendicular to line DC. And then we've got another square here. That's line GH meeting line DH. Line GH is perpendicular to line DH. There are some other lines that look like they're perpendicular, but again, we can't just assume that they are. The last type that we're going to learn about today are skew lines, S-K-E-W. That's probably a new term for you. Skew lines are lines that are not parallel, but they don't intersect either. There are a whole bunch of them in this diagram. Now remember, this is a three-dimensional diagram. Let me give you a couple of examples. For example, line GH and line, we'll say line CF. CF is going vertically in the back. GH is going horizontally in the front. They're never going to intersect each other, but they're not parallel either. When you get into 3 dimensions, not everything is either parallel or perpendicular. You have things that are neither. Let's do another one. What if I said line FH or HF? There's not a sign for skew, partly because it's such a short word, and also because, well, we don't use it all that often. It's a good question, though. What line, there's a couple of them that would be skew to HF. Can anyone give me one? BE, yes, absolutely. Good job. Those two lines don't intersect, but they're not parallel either. They are skew lines. And then parallel planes are planes that do not intersect. For example, in this plane, plane ABE, ABE is this whole side over here. And plane CDF, CDF is this whole plane over here. Those planes are parallel to each other, sort of like the floor and the ceiling in the room are parallel to one another. All right, the second part is all new terms for you. You do have to know the terms. So this first one blank is a transversal. It's a line that intersects two coplanar lines in distinct, and when they say distinct, they mean different. If something has a distinct taste, it doesn't taste like anything else. Nothing else is really even close to it. Anytime you see an English word that starts with trans, that means to cross. So for example, in social studies, at some point, you'll talk about the Transcontinental Railroad, which went all the way across North America from the East Coast all the way to the West Coast. Also, one from history, at one point they laid a cable that went from, I want to say from New York to England, all the way across the Atlantic Ocean. It was actually a telegraph where they could send telegraph signals across. This is way, way, way before the internet. Okay? It was called the transatlantic cable. Trans means cross, Atlantic, well, obviously, it crossed the Atlantic. So anytime you see the word trans, that means to cross or to move from one place to another. Transportation. Cross from one port to another port is literally what it means. Okay? All right. Notice in this picture, C is a transversal for lines A and B. And notice there are 8 different angles that are formed. There are 4 here and 4 here. Every one of those is a vertical angle with something, and it's a linear pair with 2 other somethings. So for example, here and here, what kind of angles are those? Those are vertical angles. And then down here, what kind of angles are these 2 angles? Pardon? Yeah, linear pair. They're a linear pair of angles. So everywhere you've got vertical angles. Remember, vertical angles are always the same size. They're congruent to each other. And then we also have linear pairs. Those always add up to 180. That's going to be really important for the unit we're about to start. By the way, today's notes are not on our next test. Our next test, I believe, is Thursday. And tomorrow, we have a quiz on angles. All right. But none of this material will be on either the quiz or the test. Okay? All right. So, some more terms. Corresponding angles. Are in the same position relative to the 2 lines in the transversal. For example, if we look at this group of angles down here, angle 1 is above the transversal. Remember, the line that crosses the other 2 is the transversal. It's above the transversal, and it's to the left of its line. Now, if I move, remember, trans means to cross or to move, to this set, what angle in this set is above the transversal and to the left of its line? Angle 5, exactly right. So that's one pair of corresponding angles, angle 1 and angle 5. What angle does angle 2 correspond to? Yes, thank you, ma'am. Corresponds to 7. Corresponding in math just means matching. What does angle 3 correspond to? To angle 6, good. So angle 4, right, corresponds to angle 8. All right, the next term is alternate interior angles. Alternate interior angles. So alternate just means one side then another, or one thing then another. So for example, you might have a diet where you alternated what you had for dinner every night. You had chicken on Monday, you had fish on Tuesday, chicken on Wednesday, fish on Thursday, and you just alternated back and forth, back and forth. That's alternating. Interior means they're in between the 2 lines. So angles 2, 4, 5, and 6 are interior angles in this diagram because they're in between. So what I want is non-adjacent, not next to. So 2 doesn't go with 4. That are between the 2 lines. So could be 5 or 6, but we want them to be on opposite sides of the transversal. 2 is above the transversal, 6 is below, so that would be angle 2 and angle 6. There's another pair, and it is angle 4 and angle 5. 4 and 5 are not adjacent. They're between the two lines, and they alternate sides of the transversal. 4 is below the transversal, 5 is above. We can also have alternate exterior angles. These are also non-adjacent angles that are not between the two lines. So between the two lines, internal, not between the two lines, external, and on opposite sides of the transversal. So for example, angle 1 and not 3, because those are adjacent. 7 and 8 are the other exterior angles. I want them to be on opposite sides of the transversal, so that would be angle 8. And then angle 3 and angle 7. And then the last type that we're going to learn about today are called same side interior angles. Same side interior angles. Those are the angles that are between the two lines on the same side of the transversal instead of on opposite sides of the transversal. So that would be like, for example, angle 2 and angle 5. And angle 4 and angle 6. So let's practice using those terms. In this diagram, I want to name all the pairs of angles that are of the type alternate exterior angles. So alternate, opposite sides of the transversal, exterior, not in between the two lines. I'll take a volunteer for that. Anyone got that one?
1 and 6.
Very good. Angle 1 and angle 6. Yes, sir.
2 and 7.
Very good. Angle 2 and angle 7. So corresponding angles. Who can give me a pair of corresponding angles where they match up in the same location?
2 and 8.
2 and 8? Yes, sir. Good. Somebody else give me another pair of corresponding, yes?
3 and 6.
3 and 6? Yep. There are others. Hang on just a second. Sasha? 1 and 5? Yes, ma'am. And there's one other one. 4 and 7? Yep. All right, next we want same side interior angles. Angles that are on the same side of the transversal that are in between the two lines. Andrew?
3 and 8.
Yes, angle 3 and angle 8. Good. Somebody else give me another pair. Maybe someone who hasn't volunteered yet. Oh yeah, Paige.
Angle 4 and 5.
Yeah, angle 4 and angle 5. All right, and then alternate interior angles. What's angle 4 and alternate interior angle with? Anybody?
8.
8. And then angle 3 and angle 5. All right, we're going to zip through these pretty quickly. For each angle pair, identify the transversal. The transversal is the line that joins them. It's the line that is a side for both of those angles. So, and then classify the angles. So angle 1 and angle 3. So 1 and 3. The line that joins them right here is the transversal. So that's M. When you're doing this problem, we're just looking up here. You don't want to scratch that out because we're going to need it in just a minute. But put your hand over it or something. You don't need to look at that part. So we're just looking at this part up here. Here's my transversal. What type of angles are 1 and 3? Are they alternate interior, alternate exterior, corresponding, or same side interior? Yes, they are corresponding. How did you decide that?
Notes.
Could you be more specific?
Like they're both on the bottom.
All right, they're both on the bottom and
One is exterior.
they're both to the left of their respective lines. They're in the same position. All right, angle 6 and angle 2. So if I'm looking at 6 and 2, here's the line that joins them. The transversal is going to be N. Six and 2 are alternating sides of the transversal, so they can't be corresponding. And they're between the two lines, so that's alternate interior angles. For 1 and 4, again, we're back to using the transversal M. Yeah.
What is like the angle S?
I'm sorry?
What is like the angle S doing?
What is the angle?
It's like to the right of the, like right next to the alt in. What is like the angle? Yeah,
Oh, INT. Sorry.
but to the right of that.
Angle. Oh, that's an S to make angles instead of having to write out the word. All right, 1 and 4 are alternate exterior angles. All right, we are out of time. The assignment today is in the book. And I'm sorry we didn't get through all the examples, but I think you got a pretty good idea.